Welcome to qnawire.
So in our problem, we have a helium balloon. It starts at a temperature of 10 degrees Celsius at temperature of 10 degrees Celsius, at sea level. So the pressure is P naught, where P naught is the standard atmospheric pressure, and it goes to a high altitude where the temperature is minus 50 degrees Celsius. And let's say the new pressure here is P. If the initial volume was V, the final volume was 20 V. Now we want to find the final pressure P. It is very simple. We use our formula nRT is equal to PV. So using this formula, we can see P is equal to nRT by V, where nRT is our new temperature, minus 50 degrees Celsius, but in Kelvin. So that's 273 minus 50 divided by our volume is 20 V. So that's 20 V. Now, remember that for the initial case, for when the balloon was at sea level, we can also write this equation, and we can write P naught is equal to nRT by V, which translates to nR. The temperature there, though, is 273 plus 10 degrees Celsius. So that's 273 plus 10 Kelvin divided by the volume is just V. Now we simply divide these two equations. If we divide the second equation by the first equation, we get P by P naught is equal to this whole term divided by this whole term. So that's nR times 273 minus 50 is 223 by 20V divided by this whole term, which is nR. 273 plus 10 is 283 divided by V. We can cancel our nR, we can cancel our V, which gives us P is equal to P naught times 223 divided by 283 into 1 by 20. Simple as that. Our P naught is our standard atmospheric pressure, which is 1.01 into 10 power 5 Newton per meter square, times 223 by 283 into 1 by 20 turns out to be 0.0394. So this turns out to be 0.0399 into 10 power 5 Newton per meter square, which is 3.99 into 10 power 3 Newton per meter square, which is about 4 into 10 power 3 Newton per meter square. Now that we have the absolute pressure, we will find our gauge pressure. Our gauge pressure is simply our absolute pressure minus the atmospheric pressure, which is, we saw that our absolute pressure was 4 into 10 cube Newton per meter square, minus our atmospheric pressure is 1.01 into 10 power 5 meter per second square. Notice that we can write the second term as 101 into 10 cubed meter per second square. So 4 minus 101 is minus 97. So that's minus 97 into 10 cubed Newton per meter square. I'm sorry, it's Newton per meter square. So this can also be written as minus 9.7 into 10 power 4 Newton per meter square. And this is our gauge pressure. Notice that our gauge pressure is negative because our absolute pressure is less than the atmospheric pressure. Simple as that.